What if the future of Xbox isn't a console sitting under your TV? What if the future of Xbox is the internet connection itself? For decades, gaming companies have fought the same battle: better graphics, faster processors, more powerful hardware. But in 2026, there's a bigger enemy than weak hardware: distance. The physical space between you and the machine running your game. No matter how powerful cloud servers become, every button press still has to travel across real-world infrastructure. Every jump, every shot, every dodge still has to move through miles of fiber optic cable before the game can respond. And that's where the next gaming war may be fought. Not in living rooms, not in data centers, but in the physical pathways connecting them. Today we're exploring a disruptive possibility. What happens if Microsoft stops thinking like a console manufacturer and starts thinking like a network operator? What if the real strategy isn't building a more powerful Xbox? What if the strategy is controlling the route your data takes to reach one? Because if cloud gaming is going to replace traditional hardware, there's one problem that must be solved first: latency. And latency is governed by the laws of physics. Cloud gaming has improved dramatically. 5 years ago, many players could immediately feel the difference between playing locally and playing through the cloud. Input delay was obvious. Image quality fluctuated. Fast-paced, competitive games felt sluggish. Today, the technology is significantly better. Servers are faster, video encoding is faster, networking hardware is better, AI-assisted compression has reduced bandwidth requirements. But despite all of these improvements, one obstacle remains stubbornly difficult to eliminate: the difference between player and the server. Think about what happens when you press a button. That signal leaves your controller. It travels through your home network. It reaches your internet provider. It passes through multiple routing points. It eventually arrives at a remote data center. The game processes the input. The resulting video frame is rendered. The frame is compressed. Then everything travels back to your screen. This entire round trip must happen in fractions of a second. Even tiny delays become noticeable. And unlike processing power, this problem cannot simply be brute forced away. The closer you get to perfect responsiveness, the more physics become your enemy. The industry has spent years making servers faster, but eventually the servers stop being the bottleneck. The distance becomes the bottleneck. This is what I call the latency ceiling. A point where improvements in hardware deliver diminishing returns because the signal still has to physically travel through the world. A point where improvements in hardware deliver diminishing returns because the signal still has to physically travel through the world. And that's the challenge cloud gaming faces in 2026. Not a lack of compute power, a lack of proximity. To understand why this matters, we need to talk about the speed of light. The speed of light sounds unimaginably fast. Light can circle Earth multiple times in a single second. On paper, that seems like more than enough for gaming. But there's a catch. Data moving through fiber optic cables doesn't travel at a full speed of light in a vacuum. It moves slower, roughly 2/3 the speed of light. That means every mile adds a tiny amount of delay. A few miles isn't a problem. Hundreds of miles start to matter. Thousands of miles become significant. Now remember that cloud gaming isn't a one-way trip. The signal must travel to the server and back again. Every additional mile affects both directions. Then we add processing time, routing time, switching time, encoding time, decoding time. The milliseconds start stacking up. And in gaming, milliseconds matter. Professional players can detect delays that casual users might never notice. Competitive games live and die by responsiveness. The challenge isn't that data moves slowly. The challenge is that the laws of physics set a hard limit on how fast it can move. You can optimize around that limit, you can get closer to it, but you cannot eliminate it. Which means the only real solution is reducing the distance itself. Here's something many people don't realize. The shortest path between 2 points is rarely the path your data actually takes. The public internet wasn't designed specifically for gaming. It was designed to move enormous amounts of information efficiently and reliably. That means your gaming traffic shares infrastructure with everything else: video streaming, business applications, software updates, cloud storage. social media, millions of simultaneous activities. When data leaves your house, it doesn't necessarily travel directly to its destination. It may pass through multiple routers, multiple exchange points, multiple networks owned by different companies. The route chosen is often based on network agreements, economics, and traffic management rather than pure geographic efficiency. So even if a server is relatively close to you, the data path may not be. Think of it like driving. The destination might only be 10 miles away, but traffic detours and road design can turn that 10-mile trip into a much longer journey. The internet works similarly. Every additional hop introduces potential delay. Every routing decision introduces inefficiency. Every congested segment creates friction. For streaming video, these delays are usually insignificant. Netflix can buffer, YouTube can preload, cloud gaming cannot. Cloud gaming needs immediate interaction. Every button press demands a response right now. And that requirement exposes every weakness in traditional network routing. For decades, the solution was simple. Put the hardware in the player's home. A console solved the latency problem because the game ran locally. The processing happened a few feet away from the screen. Input response was nearly instantaneous. The internet was optional. But cloud gaming changes the equation entirely. Now the hardware exists somewhere else. Maybe in a regional data center, maybe in a cloud facility hundreds of miles away, maybe eventually in infrastructure scattered across entire countries. The moment the hardware leaves your home, network quality becomes part of the gaming experience. This creates a fascinating shift in priorities. Historically, gaming companies competed on hardware specifications. More teraflops, more memory, better graphics, faster storage. But if processing power becomes centralized in the cloud, those traditional advantages become less important. The question is no longer how powerful is the box under your television. The question becomes, how quickly can you reach the hardware running your game? And that transforms the entire business. Now let's explore the big idea. This section is strategic and under huge speculation, not a statement of confirmed Microsoft activity. The concept is simple. If latency is caused by distance, move the gaming hardware closer to the player. Not just closer, dramatically closer. Instead of relying exclusively on massive centralized data centers, imagine deploying Xbox cloud infrastructure deeper into local networks, into regional hubs, into edge computing facilities, locations physically closer to neighborhoods. The goal wouldn't necessarily be building bigger servers. The goal would be shortening the journey. Every mile removed from the route reduces latency. Every eliminated network hop improves responsiveness. Every local processing node brings cloud gaming closer to the experience of native hardware. Suddenly, the battle isn't about console power. It's about infrastructure placement. The winner becomes the company that can position computing resources closest to users, and that changes everything. Traditionally, Microsoft sold hardware. You bought the console, you took it home, you owned the gaming experience. Cloud gaming just introduces a fundamentally different model. The company controls the hardware. The user accesses it remotely. But there's another level beyond that. In theory, the closer a gaming provider gets to controlling network infrastructure, the more variables it can optimize. Routing, traffic prioritization, regional deployment, edge computing, load balancing, latency management. The focus shifts from individual devices to the entire delivery system. Think about how streaming video evolved. Success wasn't only about content, it was also about content delivery. The companies that mastered distribution gained enormous advantages. Gaming may be approaching a similar transition. The experience becomes increasingly dependent on the quality of the network path itself. In that world, infrastructure becomes a competitive weapon. If cloud gaming eventually reaches true console-level responsiveness, the implications could be enormous. The traditional upgrade cycle becomes less important. Consumers no longer need to buy increasingly expensive hardware every generation. The most powerful gaming machine exists somewhere else. Always updated, always maintained, always improving. The local device becomes a window into a remote computing platform. A television, tablet, handheld, a phone. anything capable of displaying a stream. At that point, ownership of physical hardware matters less than access to computing resources. And access depends on infrastructure.